Welcome back to day 2 and the conclusion of EPRI's AI and Electric Power Summit. If you missed us yesterday, I'm Christine Rivers. I lead EPRI's communication support for artificial intelligence and will be your MC to take you through the sessions once again today. If you weren't with us yesterday, quick tour of our virtual platform. The agenda is displayed next to my video screen here. Down below the display, you see a QR code that will give you the link to provide questions, comments, any input through sessions 2 and 3 today. As we did yesterday, the breaks will have a short video project update as well as another quick video highlighting some of our EPRI AI work. So first up, we've got a real exclusive for our AI Summit. As we all know, schedules for executives can be a challenge, but in this virtual setting, we can have interviews and conversations recorded like news outlets do for a broadcast. So 2 weeks ago, EPRI Senior Vice President Neil Wilmshurst, who oversees our artificial intelligence research, met with C3 AI CEO and Chairman Tom Siebel. And Tom and Neil discussed the barriers of the electric utilities have had to overcome, what one of the most successful energy companies in the world has done to implement enterprise-wide AI, and a host of really other insightful topics, sort of inspired by our past AI events and to the summit's theme of scaling and accelerating AI. So enjoy, and I will see you back here in 45 minutes.
Okay, everyone. Hey, good morning, good afternoon, wherever you may be. We're here actually 2 weeks prior to the AI Summit, here with Tom Siebel, Chairman and CEO of C3 AI. And today we're going to have a discussion with Tom to understand his perspectives on AI and how C3 AI has actually addressed those. So before we start, a quick context setter. You know, everyone goes through their career doing different things and finding different opportunities along the way. And my career has been no different. I started in the UK, actually in a university town, the number 3 university in the UK, apparently, Durham University, surrounded by really smart people doing really smart things. Never heard about AI. Joined the Royal Navy, end of the Cold War, under the ice, lots of analog controls, lots of intelligence data flowing around, not a word of AI. Joined the civil nuclear program, lots of sensors, lots of data, and the reality was overwhelmed with information, and we really struggled to understand what the information was telling us. And then over the last 4 or 5 years, the real potential of AI has come very apparent to the electricity industry and the power that might be there. And as I look back, I think about one of the opportunities that I, in retrospect, saw, and this has defined my vision of AI. The guy who manages a nuclear power station is a really, really important person, and he's surrounded by data input. And that data is hard data from sensors, it's weather data, it's the smell of a building, it's the noise in a building, it's the people around and whatever. And those guys come up through the ranks and train and become that experience. One particular guy I worked with at one of the plants I worked on was an absolute superstar as a plant manager, which was wonderful. That plant ran really well, but it was all based on what he knew, the judgments he made. What terrified us was what happened if he left? How did we replace that person? And my vision of AI is there a way you can come up with a decision assistant that actually provides a regular person, not that superstar plant manager, with all that information, all that context, all those decision aids in order to run a nuclear power plant safely. So that's where I'm coming from in AI, and I really want to see how we can get there one day. And just before I hand over to Tom, I've just today done my daily AI experience. I've been running my Roomba robot vacuum around the house. So AI in action, Tom. So Tom, you know, you're doing so much more than robot vacuum cleaners at C3 AI. So I wonder, just as a kind of a starter, can you give us some context about how this all started and where C3 AI came from?
Well, this is my fourth decade in the information technology industry. I did my graduate work in computer science at the University of Illinois in relational database theory. And I went to work for a little startup company called Oracle Corporation that had about 20 people and was just about to do 2 million in revenue. And that turned out to be a pretty good idea. And I was one of the guys who built that company and helped establish Oracle as as in a leadership position, first in relational database technology and then in application software. About a decade later, I spun out and we started a company called Siebel Systems, which was about applying information technology and communication technology to the business processes of sales, marketing, and customer service. And so we had a big step function of information technology that came online in the early and mid 90s that would include graphical user interface technology, introduced primarily by Windows 95, and the World Wide Web, or the internet as we know of it today, which kind of spun out of the University of Illinois with Mosaic, the Mosaic browser, and Mark Andreessen, nomadic laptop computing, high-speed relational database technology, and then broadband with communications. So the idea at Siebel Systems was to take this step function of technology and point it at the value chain of sales, marketing, and customer service. Well, in so doing, became a large global company very rapidly. 6 years later, we were doing about 2 billion in revenue, and we invented this market that we all know of today as CRM. Today, it's about a $60 billion market today, and the sum of the investments in CRM systems across all industries is well in excess of $1 trillion. We sold Siebel to my friend Larry Ellison in January of 2006, and we started thinking about what was going to happen next in information technology, and it occurred to us that there was a new step function of technology coming online that was going to change everything. Meanwhile, the information technology business has grown from 1980 to 2006, say from, well, it was about $200 billion in 1983, and today it's about 4 trillion. So it's grown. And look at what's really driving growth today is this new step function of technology that includes elastic cloud computing, the Internet of Things, big data, and predictive analytics. So these technologies, at the convergence of these technologies is where C3 lives. And we're about applying these technologies to solve very large scale, enterprise scale AI applications across a wide range of industries: utilities, oil and gas, aerospace, manufacturing, precision health, government services, telco, to solve classes of problems that have never been solved before. So we've spent about the last decade and about $1 billion building a technology stack that allows us to solve very large scale enterprise AI applications. And one of the first areas we were focused on was smart grid analytics for large grid providers like Enel and Engie and Con Ed, what have you. And those are, very, very interesting, very complex problems of enormous social and economic benefit.
Right. Well, Tom, it's phenomenal what you've achieved in as you say, all these decades you've been working on this. So the way AI has progressed is been quite amazing, even for someone like me who's only recently kind of delved into the history of AI. So by the time our attendees hear this, they'll have gone through the first day, they'll have heard about from people from NIPA and some of the other people you've been working with over the years. So we all have our vision of AI. I have my vision around this nuclear plant manager decision assistant. Everyone's got their own idea what they're going to do with AI. But when you worked with NIPA and NG and NL, what were some of the barriers you saw that they as an organization needed to kind of figure out and crash through in order to move the ball forward?
Well, first of all, I share your vision that part of AI is taking this great genius, this Obi-Wan Kenobi, and there's one in every nuclear plant, and there's one in every aircraft hangar for the Navy, and there's and there's one in every this person that can just close his eyes, and put his hand on the side of a transformer and exactly know when it's going to fail. And part of AI is about in capturing that knowledge in machine learning models. A part of it also is with these new technologies, including the censoring of the value chain with the grid becoming the smart grid, so that all of the devices in the value chain are now becoming remotely machine addressable, be it a thermostat or a smart meter or a phasor measurement unit or whatever it might be, transformers, substations, reclosers. All of these devices are becoming remotely machine addressable. So now we're dealing with data sets the size of which were formerly, unmanageable. We're dealing with data velocity that is mind-numbing, with some of these data arriving at like 90 hertz cycles. And so we're dealing with problems that are candidly impossible for human beings to solve. I mean, human beings just can't deal with that much data coming that rapidly. And so another aspect of AI is to be able to aggregate these data into a unified federated image, process the data at the rate they arrive, and apply machine learning to find the meaning. Okay, so now what was the original barrier? I'll remember in 2013, sitting in the boardroom at Enel in Rome, with all the CIOs leaning back with their arms crossed, saying, "Tom, what don't you understand about how our data will never be in the public cloud?" So I would say the first obstacle was the internet. Well, we seem to be getting over that. Okay, now 8 years later, Enel has closed 23 data sets data centers around the world, and all of their data are in the public cloud. So everybody's kind of getting over that issue. I think the technical problems are a source. I'll give you a feel for Enel. Enel, I believe, is the largest AI project in the free world. I believe it is the most advanced company in smart grid analytics in the free world. Their CEO, Francisco Strachey, is a great visionary, and he has been personally driving this vision. So at Enel, and Enel runs, it's a pretty big grid. They have 60 million meters in 40 countries. In Spain and Italy, they have 42 million meters, 60 million meters. I mean, as you people know better than I, there's roughly 100 million meters in the United States, run by, I think, 1,350 utilities. So this is a pretty big grid infrastructure. And in that infrastructure, we have aggregated data from 42 million smart meters, 47 million sensors, I think 18 instances of SAP, maybe 10 to 20 instances of Salesforce, Siebel, Dynamo, Atlas, two different SCADA systems, one from Siemens and one from Schneider. And then we go out to the extranet for open source data for weather, terrain, social media. That gets updated 62 billion times a day. So there's 100 trillion rows of data aggregated into a unified federated image. And and some of these data are arriving at like 90 hertz cycles. So we process these data as they arrive, and we have to deal with all the issues that you all think about: authentication, access control, security, GDPR, privacy, but just so encryption in motion, encryption at rest. But then we apply machine learning models to these data as they arrive to basically allow Enel to deliver safer, cleaner, more reliable energy. If you look at the SAIDI scores at Enel, they're pretty remarkable. Okay, if you look at their cost of operation, it's pretty remarkable. But we're doing everything from predictive analytics for AI-based predictive analytics for power generation, AI-based predictive analytics for hundreds of millions of devices in the and transmission and distribution system, transformers, substations, reclosers, capacitance banks, integration of renewables, volt var, cybersecurity, distributed energy resource management, energy efficiency at the edge. So Enel is looking for Francisco Zarachi at Enel is looking for 5.1 billion euros in recurring economic benefit from these initiatives. And I believe that this is not only the most advanced, I'm confident, okay, this is the most advanced utility in the use of AI in the free world. Um, um, this is probably the largest production AI application footprint in non-classified space on Earth. And so there, I think Anel and Francisco Strachey represent the high watermark in the space.
So, Tom, you touched on something there which is really interesting, I think, for our participants here. It's around, okay, you can have this vision, you can set off on a journey, but are there metrics that you would think could be useful as you set on that vision? You mentioned NL and their desire for quantifiable savings. Are there any other metrics you'd recommend people think about?
Well, SATI scores are a good one. Okay, that's pretty good. Your cost of delivery is pretty good. How about safety? I mean, the idea, to what extent can we identify device failure before it happens? Okay, so that the transformer doesn't blow up in Northern California and take out 5,000 people with it. Okay, by the way, the lights don't go out in Rome. So the social and economic benefits of that are obvious and really quite dramatic. I think so. Where's the catch? What's the hard part? I mean, the hard part is, let's look at Enel. Enel, as I recall, has I think they have about 37,000 employees, as I recall. They're all operating in highly socialized countries like the United States, where they have completely unionized with workers' unions. And they all have labor contracts. And all these labor contracts say how people are going to be compensated, what they're going to do from 8 in the morning till 5 or whatever their hours are, how they get promoted. And now we're going to use AI to fundamentally change everything about their jobs. And people are threatened by this technology. And so if you're going to get, I would argue that we have trivialized the problem of data aggregation. We have trivialized the problem of designing, developing, provision, and operating these smart grid analytics applications. We do it all over the world. We do it at ENGIE, we do it at Con Ed, we do it at New York Power Authority, we do it at Duke. Utilities are no longer our largest segment, but it's a big business for us. Now, the hard part is no longer dealing with big data. It's no longer dealing with the cloud. It's not dealing with security. It's not the IT problem. The hard part is the change management. People find this technology threatening. They believe it threatens their jobs. And by the way, in some cases, it does threaten their jobs, okay? It does threaten some jobs. I think net there will be more jobs when we're done than less, but some jobs are threatened. And so I think that while these people who are really succeeding in utilities, in oil and gas, in aerospace, in manufacturing, have great leaders that really understand change management and understand this is not something you can really delegate to your CIO. I mean, this has to do with the fundamental culture of the company and who we are and what we do. Let's look at Royal Dutch Shell. Royal Dutch Shell, I think, is the 5th largest company in the world. I believe they're the 2nd largest petrochemical producer, hydrocarbon producer in the world. Huge C3 AI footprint, upstream, downstream, midstream. And they're using AI to fundamentally transform the company to a zero net carbon footprint by 2050. Come on, this is Shell. This is all they do is produce hydrocarbons. And this takes leadership. And I would say that this is really the challenge. And this is not something that the CEO is going to be able to delegate. This is something where the CEO needs to lead, and he or she needs to be out in front pulling, or you're going to do all this work and you're not going to realize any social or economic benefit because you're going to get too much pushback from your employees.
Right. This is really interesting. We were talking before we started recording this about the current energy transition and climate change and how you got started in this field by thinking about those issues. And your comments about Shell and other companies working in the AI space, it occurs to me that the energy industry, the electricity industry, is really playing catch up in this space. We seem to have been on our back foot watching other people with AI, and there can be excuses. Nuclear industry will say, well, we need to make sure we understand AI, we make sure it's safe. Another part of the industry might have concerns around the ethics of AI and the decision tools and how much AI is allowed to do and how much AI can just advise. And then the issue about the job security, the training, and everything else. These are all complex and intertwined. I don't know what you think about the context we're in now in the electric industry, and are we behind the curve? And what do we do to catch up to address all those complicated issues?
I think it varies quite a bit geographically, and I know this is not going to be a very popular statement, and I'm certain you'll never have me back again for saying this. But I think the utility industry actually might be the most advanced in the use of AI, and I think the most advanced utilities in the world in using AI are State Grid and South China Grid. And these guys are all over it, okay? And what they're doing is really impressive. And they have been at it at massive scale, going back to say, 2009, 2010. And what they're accomplishing is truly remarkable. Second behind China, and by the way, we don't do business in China. China's just gotten too complex with intellectual property and all this kind of war that's going on in AI between China and the Western world. And so we just decided to sit that out. And while we used to be swarmed by the Chinese and they would, 50 of them at a time would come through our offices with all their cameras, we made the decision that we don't do business in China, and I feel comfortable with that. Now, behind China, you have Europe. Okay. And I'd say Europe is some of these European companies are relatively advanced in their use of AI. And now these guys know exactly what they're doing. Okay. Some of the work that's being done at NG, okay, in smart cities and smart institutions is really quite impressive. I would say in way behind China and Europe is the United States. Okay, and the United States has not been really applying AI because the regulators have not been telling utilities to do it. Okay, and as far as I can tell, the utilities in the United States do what the various regulators instruct them to do. And so the concentration has been on, reducing consumption, 1% a year at the retail level, and issues like that, rather than, when's the last time the regulators at CPUC in California came down with a mandate about using AI to increase safety in the grid infrastructure? Well, that would be never. Okay. And that's why, California is on fire. And so I just don't think there's been a mandate from the regulators in the United States to apply AI to deliver safer, cleaner, more reliable, more secure energy. Cybersecurity. There's the 800-pound gorilla in the room that we might want to talk about. So there's not a mandate to deal with that, and so the utilities are doing as they're instructed, and this just is not on the list.
So you've opened the door, cybersecurity and data. As we at EPRI have kind of moved forward on our AI efforts, one of the challenges has been that access to data. In order to work in AI space, you need data, you need lots of data. The cybersecurity impact on the electric industry and other industries can tend to make people very reluctant to share that data. How do you think the industry can come together to help each other to break down those barriers. Because without the data which is in the industry, it would appear that it's very difficult for the AI community to help the electric industry.
Well, we know that the power grid and the US power grid is being penetrated by bad actors every day. This has been well documented. There's in, any number of books. Everybody remembers, Lights Out. Okay. There's a book that's been written. It's called The Perfect Weapon by David Sanger. I strongly recommend it, about what's been going on with all these cybersecurity attacks around the world. The Wall Street Journal has definitely documented this. So the grid is highly permeable. It is being penetrated. It can be secured. The way it will be secured is with the use of AI. There just needs to be a mandate to do it. It is a very real problem, and with the advent of the smart grid, the attack area, the surface area available for attack has become orders of magnitude larger. But it can't. But it is a securable infrastructure, and we just need the will and the budget to address it.
Yeah, I'm with you, Tom. I'll tell you, as I look at the energy transition and the way the grid is becoming more complicated, I think at the very start of this, you talked about grid operations and everything else. It's, to me, it's complicated enough today to visualize how the grid is managed, all those decisions, all the different moving pieces to keep that reliability there. And just imagine the future as we go forward with those different distributed resources, electric vehicles, discharging into the grid, and all those different activities. I, for one, cannot see a way that we can manage the grid without application of AI to help those decisions. So I think you're right. I think we do need to figure out a way that data is freed up and made available to actually keep the reliability and resiliency up there.
And this idea that the cloud, I mean, there's no question we can secure data in the cloud. We can secure data. I believe we can secure data in the cloud easier than we can secure it behind the firewall. So we just kind of need to get over that. But it is an AI problem. The state of the art in cybersecurity of corporate information technology systems is, somebody you can read up there. Those who are interested might want to read The Perfect Weapon by David Sanger, or there's another very interesting book called This Is How They Tell Me the World Ends by Nicole Perlroth, both from the New York Times. They're fascinating books, and it is very scary how vulnerable these systems are. Not only the grid infrastructure, the financial services infrastructure, and the Department of Energy, and the Department of the Navy, and the White House, and the Democrat National Committee. So they're all vulnerable. Sony, they're all vulnerable. They're all wide open, and they get penetrated every day.
So, we, by virtue of the fact we're here, you and I and the attendees who are watching this, we're by definition pro AI, or at least interested in the benefits of AI. Do you ever come across people who are just firmly against AI? And how do you deal with them if there are such people out there?
I think that that where you run into people that are against AI, I think that their concerns are really quite legitimate, and they're concerned about the privacy issues and security issues associated with artificial intelligence that really are very real and very important. Um, and the idea that whether it's a public sector organization or private sector organization, the thought that they will not misuse these data or use these data in malevolent ways is unthinkable, because they will. See Facebook for details. And let's take precision health, for example. We will very soon, today, we have the capability to aggregate the genome sequences in the healthcare records for, say, the population of the United States into a unified federated image. and then we keep that image current in near real time, and apply AI to those data to do, for example, disease prediction. We'll be able to predict who in the population is going to be diagnosed with what disease in the next 5 years with very high levels of precision. And then we're going to be able to, we can intervene clinically to avoid the diagnosis. And by the way, you combine that kind of capability with this kind of device, and we're gonna serve, previously, massively unserved, historically unserved audiences, communities, AI assisted medicine, genome specific medicine. I mean, this will be the largest commercial application of AI, and people will live longer, they will be healthier, healthcare will be more available, and it will be at lower cost. So this is all motherhood and apple pie, right? This is a great thing. Now let's think this through. How is this insurance company or this single care provider in the case of government going to use these data? I mean, do you want to know you're going to be diagnosed with a terminal illness in the next 3 years? I'm not sure I do. Okay, who cares about pre-existing conditions when we know what disease you're going to be diagnosed with in the next 3 years? And the idea that these data won't be used to ration, they will be used to ration medicine in some countries, perhaps not the United States, pray not the United States, but it will be used to ration health care. The economic decisions will be made that it's not in the economic best interest to perform surgery on this person because he or she is, perhaps overweight and, over 70 years old or whatever it might be. So the privacy and security issues associated with these data with AI are really troubling. Okay, and we need to think about it very carefully, or these data will be misused, and the consequences of this are really deleterious. Let's look at what's going on in social media today, where these social media companies are, using these devices, okay, to get people to manipulate 2.2 billion people at the level of the limbic brain. Well, the limbic brain is the brain stem that emits dopamine, and this is addictive behavior. And so we have 2.2 billion people addicted to this device, and we know what it is doing to young people in America, particularly young women with self-image issues, but men too, self-image issues, loneliness, depression, suicide. I mean, it just makes you want to cry. Okay, and it's going on every day, and they have scientists that have figured out how to get to people to do it more. These devices are being weaponized by bad actors in rogue states, which question the result, question whether or not we're going to be able to conduct a democrat society. And these people who are operating these companies are able to look the other way because they're making money. I mean, how do they look at themselves in the mirror in the morning? As we get into the power grid and we get into the financial infrastructure, I mean, it's a fact. I know that people don't want to admit it, but it's a fact that people could switch off large sections from the grid from a device like this in St. Petersburg, and it can be done. And so this is really, really troubling, and we need to face it. We need to look it right in the eye. We can't pretend that it isn't real, and we need to address it, or else we're going to have to live there, and that will be that is going to make Orwell's 1984 look like the Garden of Eden.
Yeah. So that notwithstanding, I think we have to move forward with the benefits of AI, but have that context in parallel that we have to address. So there's tremendous capabilities in AI. You've achieved a tremendous amount with C3 AI to date. If you were to look forward in the next decade, maybe up to 2030 or so, what do you see C3 AI doing in this energy transition kind of environment we're in now? Because the next couple of decades are really going to define what 2050 looks like.
Well, I think we will see all the major oil and companies reinventing themselves as clean energy, new energy companies. Okay, and they're not going to do this, I think, through political pressure or through the professor for really for you know, environmental reasons. Okay, they're going to do it. They're doing it out of profit motive. Okay,
Yeah.
I believe that Francisco Starace is reinventing an Enel. Okay, as a clean energy utility for profit reasons. He can make more money that way. He can reduce. He can return a greater return to his shareholders that way. So the motivation is pure. And now we will use AI to completely address this problem of distributed energy resource management. And that's enormously, this is a non-trivial problem. Okay, integration of renewables will be, to the extent that we are drilling, to the extent that we are fracking, to the extent that we are transporting, to the extent that we're refining. Okay, we will do that in a safer, cleaner, much more environmentally friendly fashion. We will be using AI-based predictive analytics to predict device failures before we have failures on offshore oil rigs. Okay, we'll predict device failures, even at PG&E, believe it or not. Okay, before the transformer blows up and burns down half of Northern California. So AI will be the enabling technology that enables utilities and oil and gas companies to deliver cleaner, safer, more renewable energy at lower cost into the hands of more satisfied consumers. So it will change everything.
So that is a really compelling message. And I tell you, as I look into the coming decades, it's really daunting what we have to do. And I'm convinced, I was convinced before we start this conversation. I'm more convinced now, though, that AI has a real key role to play going forward. And as you mentioned, every utility, every stakeholder in this industry is in a different place. NL would appear to be in the lead. We've got other utilities, maybe NIPA is doing quite well. There's companies in Canada who are doing some good work, but everyone's got to do.
Con Ed is doing some good work. I think Duke is doing some good work. For those of you who are interested, you might take a look at the C3 AI Digital Transformation Institute. This is an institute that we put together with the C3 put together with Microsoft. We funded this to the tune of initially, I think, $300 million. And this is a coalition of some of the leading research institutions in the world, including MIT, Carnegie Mellon, Princeton, University of Chicago, University of Illinois at Urbana, UC Berkeley, Stanford, KTH in Sweden. I'm sure I missed a couple, but this is a combined research effort where we have funded, I believe to date, 29 research projects. We've given them two 26 petaflop supercomputers. We bridged that with a Microsoft Azure stack. On top of that, they have unlimited use of C3. And then we funded 29 collaborative research projects across these organizations to develop new AI techniques for distributed energy resource management, integration of renewables, predictive maintenance for wind turbines, AI techniques for carbon sequestration, what have you. And so some of you might be interested in collaborating with that research, and it's all published on the web. I think at the c3aidti.com. And all of the science, by the way, from those research projects goes into the public domain. So it's available to all of you. And I encourage you to take a look at it. And this is a project being led by Microsoft, and C3 is being managed by UC Berkeley and the University of Illinois. But when you see the substance and depth of the science that is being developed, this is kind of net new science in AI that is that's immediately available in the public domain to all of the participants in this audience and anybody associated with EPRI, anybody in the world, actually.
Tom, that's great. You answered the question before I asked it. That's probably a bit of AI going on there. As I was saying, this AI has to be part of the future. You are so engaged, as you just talked about, in developing new capabilities, new techniques going forward. So the capability of AI is only going to grow, and the challenges will be addressed as they go. And we all have this huge challenge of the climate change necessity and the 2050 goals. So as we wind down here, have you got any words of wisdom, if you like, for the participants here, for how do they start moving here? And they may not be the CEO of their company. They may be trying to stimulate this effort from lower down in the organization. So have you got any words of wisdom for how to get this momentum going?
I think the companies that we've seen that tend to be successful, like the Shells, the Enels, the Con Eds, the NIPAs, the Koch Industries, departments of the Air Force, that to the extent that we're seeing these projects succeed, it's companies that are taking tractable projects and doing it in a short period of time. Forget about boiling the ocean. Okay, if it's going to take 3 or 4 years, forget about it. Okay, and 200 consultants from name the firm, forget about it, because by the time 3 years go by, the problem statement will be obsolete. But do something concrete. Okay, take 2 million meter grid infrastructure and build and install predictive maintenance for your transmission and distribution devices. This device is a tractable problem. It should take about 6 months. If we want to do, revenue protection, that's a relatively easy problem. Okay, what do you call revenue protection in the utility industry? Everybody else calls fraud. I mean, again, just pick a relatively simple problem for 2, 3, 4 million meters and bring that application live. It's a 6-month problem. To try to solve, address the universe. Okay, and then do the next one, and then do the next one, and then do the next one, and pretty soon you have 12 AI applications up live, like Enel does. Pretty soon, it's like I think they started in 2014, so this has been a few years. But they've accomplished quite a bit, and now they're 100% in the cloud. In the cloud. But I think you got to keep it simple, keep it tractable, do it now, okay, and measure the results in economic benefit, okay, in social and economic benefit to the community, to your constituents, and to your shareholders. It shouldn't be just some touchy-feely idea of we did AI. There's no value in AI. There's only value in AI if we're safer, if we're more reliable, if it's lower cost, if it's lower environmental impact, and we can measure it. Okay, and you should have specific goals, and the only way you should measure the success of the project is in the attainment of those clearly articulated key performance indicators. So that would be my strongest recommendation.
Okay, well, Tom, I can't thank you enough for the time you spent with us today. It's great to hear from someone who's right there in the middle of this, making a difference, working with companies, who's got such a depth of experience and knowledge on what can be done and what needs to be done and what's possible going forward. And really, those last comments to people about how to get started in AI and starting small in bite-sized pieces, I think is the really important nugget today. Because we all have an instinct to, as you say, boil the ocean, go for the huge challenge. I want to go and invent that nuclear plant manager decision assistant. I want to skip all the other steps to get there. So really, Tom, I can't thank you enough for this and for the number of times you've helped EPRI over the years with your guidance and your insights. So I just want to thank you very much for your time, and I hope the participants have enjoyed it.
Neil, it was an honor to be involved and a pleasure to talk with you and to see you. So the pleasure is all mine, and I thank you very much.
Okay, great conversation there, sprinkled with insights that can be used as your companies explore endeavors in AI. I know one theme I heard today is, or from that conversation is, I think, and you'll hear it among other panels today, I think, is that enterprise scale AI deployment doesn't come with an easy button. In fact, it's very much about workplace culture, change management, trying and testing out one application, and building on that success to effectively scale up. And while some things can be done quickly, enterprise adoption takes years. But once there, the benefits are real, as Tom explained with NL. But to Neil's point, while we all have different visions of what AI can do for us, overall, AI is a key to the digital transition and reaching net zero energy transformation goals. Okay, our first break will begin with another video that we put together in just the past month and a half, right here from this building in Charlotte, North Carolina, where we're using our own facilities as a test bed for an intriguing project. So I will see you back here at 12:30 Eastern, and enjoy the video.
One of the biggest challenges that we're seeing for both building owners and for grid operators is the level of complexity for the power system is growing exponentially as more and more intermittent resources and controllable end-use applications are added to the system, driving two-way power flow, which is something that from an industry perspective we hadn't experienced in the past. How do we capture and curate the volume of data that's out there that's necessary to provide the real-time analytics that can be integrated into a grid interactive intelligence system that maximizes this opportunity? Buildings consume more than 70% of the US electricity today, and they account for at least 1/3 of the carbon emissions. A recent report from the US Department of Energy published a national roadmap for grid interactive efficient buildings. Their goal is to triple the energy efficiency and the demand flexibility of buildings by 2030 relative to 2020. According to the Department of Energy, the value that grid interactive buildings can bring to the US power system is between 8 billion and 18 billion annually by 2030. It helps us reduce carbon by about 80 million tons of CO2 annually. And then that's the equivalent, just as a benchmark for you, about 50 medium-sized coal plants or 17 million cars.
At Southern Company, we are continuously looking for ways to improve how our grid operates and develop new and innovative ways to meet our net zero carbon goals. We believe grid interactive efficient buildings can play a key role in this transition by becoming an active resource that helps balance and facilitate renewables and EVs without impacting customer quality of service. AI is the tool that can unlock this capability. Southern Company is currently leading 3 key initiatives to help understand the benefit and the role that grid interactive efficient buildings will play in the future grid. The first 2 are residential smart neighborhoods, formed in partnership with Alabama Power, Georgia Power, EPRI, and DOE's Oak Ridge National Labs. One located in Birmingham, Alabama, pairs a community-scale microgrid with light-touch energy management controls inside of each of the 62 homes. The second, located in Atlanta, Georgia, takes a similar concept and brings all the distributed energy resources back behind the meter, and each of the 46 townhomes has rooftop solar and residential battery storage. This project is currently developing AI-based controls that can balance comfort, cost with grid services. Lastly, the third initiative is a partnership with Georgia Tech to take grid interactive efficient buildings from a residential setting into a commercial campus, where we can understand how the flexibility works when the incentives better align with the customer and there's more AI-based load flexibility available. Each of the projects we're currently undertaking requires multiple layers of optimization, meaning we're balancing potentially competing objectives simultaneously. For example, using buildings for grid services while also maintaining that building's primary function. This is where AI fits in nicely, where it's able to ingest large data sets and predict the outcomes of different control approaches, leading to a co-optimal solution. We're really just getting started implementing AI at our Georgia Power Smart Neighborhood, but are already seeing cost savings reduction potential of around 20%. We're also seeing peak load reduction of 10 to 15% from some early and preliminary testing. We're really more excited to continue testing and continue improving on these numbers, but then also expanding our use cases and our value streams that can be created using AI. We're expanding our R&D portfolio to create projects that can address these gaps and overcome the barriers to create a solution where buildings can participate in short-term grid needs, but then also participate in a platform that enables our transition to a net zero carbon grid.
The benefits that AI brings to grid-integrated buildings is the ability to manage all of the building's data simultaneously without having a person in the back room trying to crunch all of the numbers, which allows the building to operate more efficiently and use less energy, as well as shift the time of use of that energy to flatten the load curve, allowing utilities to save money and not turn on peaker plants, which also helps with decarbonization efforts.
Barriers exist across the entire value chain, and the first barrier will be the lack of understanding of grid-integrated buildings. So that can lead to some reluctance from the utilities and building owners to alter their business operations. Utilities don't have 100% control over a customer's building, but the demand response and the load flexibility actually require building owners' support. In many cases, utilities would rather install a new generator or upgrade their distribution so they can for sure to have it when they need it. But that's definitely a more expensive route and emits more carbon. The second barrier would be lack of interoperability that hinders AI from larger scale adoption. And you will see that many of the building control upgrades still need to be tailored for each site. And many of the buildings that are built more than 5 years ago do not support open communication standards for grid-integrated buildings. And the third barrier comes to the inability to monetize building flexibility and AI in buildings. We know that AI is about the software and the data sets and have no capital expenses, so that's why it's hard.
We've set out to develop data predictive controls models to overcome the energy modeling complexities and avoid the repetitive building-by-building customization that can occur. We also explore data-driven pathways to accelerate global scalability of grid interactive efficiency buildings. We're looking to establish a training data set for building system dynamics and operational conditions, along with establishing guidelines for building controllers to collect data sets without impacting day-to-day operations.
EPRI's in a unique position because we work with early stage startups all the way through utilities with field implementation, and we work to scale the early stage R&D concepts up to mature, benchmarked, fully implemented solutions. We do this by working with utilities, vendors, national labs, universities, and various other government organizations.
In the way of critical research, we do three things. The first one is a digital twin demonstration for fault detection and diagnostics to improve the awareness of AI in building management. The second would be a data predictive control demonstration to accelerate algorithmic scalability and repeatable success in deployments. The third one would be a high-fidelity data set that can support advanced building controls and also inform building owners and utilities what the building is capable of, the demand-side resource.
Our demonstrations are meant to show a viable and scalable solution, and we have two different demonstration sites that we're working on. The first is based at our EPRI Charlotte headquarters, which is roughly 100,000 square feet in size. And we have a second demonstration site at a smaller office building located in San Leandro, California, which is about 23,000 square feet in size. For this project, one of the ways EPRI is helping to bridge the gap between advanced technologies of AI and machine learning is to use our own office building here in Charlotte as a test site for the Grid Integrated Buildings project. This allows us to have full access to the buildings, its systems, and all of the data for developing a solution that is truly scalable. This is one of the first grid-integrated buildings and will be an excellent test bed as we build and grow the data set that comes from the unique usage of our own facilities. EPRI has been coordinating activities with a growing group of organizations, including Stanford University, Southern Company, and the National Renewables Energy Laboratory, along with others in a goal to develop and deploy these technologies on a global scale. This effort will be included in the grand challenges that EPRI will be issuing to the AI and electric power industries.
Over the next 5 years, I really see these projects creating the foundation of how we use AI-enabled grid interactive efficient buildings in daily grid operations, and also informing how we transition and how we incorporate GEBs into utility planning exercises.
These same concepts apply more broadly when you think about homes and beyond as we continue to scale up and branch out with these technologies around the world. These AI solutions and the benefits they provide truly have the potential to revolutionize the commercial energy landscape. And EPRI's artificial intelligence R&D is committed to bringing industries together to overcome the barriers, accelerate development, deployment and adoption, and scale AI solutions for utilities and their customers.